So LeetCode get biggest 3 rhombus sums in a grid. So in this problem, you're given a grid and you need to return the top 3 distinct sums along the perimeter of a rhombus. And a rhombus is just a square rotated by 45 degrees. And also there is the degenerate rhombus, which is just a point. And so that is just an element of the matrix. So we're gonna split this problem in 3 parts. The first part is just taking the best squares in the grid, so these degenerate rhombuses. Then the second step is going to be taking the actual rhombuses, so with side length at least 1. And the third step is going to be actually calculating their sum. So we're going to have a separate function for that, which makes everything cleaner. Okay, so let's go. So the first thing that we're going to do is we're going to take the smallest dimension of our grid, because this is going to come useful when we loop through all of the cells to use them as a kind of like a center for our rhombus. And because it's a square, so the thing that bounds us is the smallest dimension of the grid. Okay, perfect. Then now we're going to do the first part. So first of all, we need our best sums that we have found so far. And then we're going to loop through all of the cells of the grid and update our best. So this is the part where we take all of the degenerate rhombuses, so just the single points, the single elements of the grid. So, and at the end, of course, we're going to return the best that we have found, sorted in decreasing order. Okay, and this is important to do, because if you don't do this, you might end up here with a best array that is not sorted. So it's important to sort it as you return it. Okay. So now that we have that out of the way, the first thing that we're going to do is we're going to loop through all of the cells and update our best that we have found so far accordingly. So we loop through all of the rows of the grid, all of the elements of that row, and we check if the best, remember that these need to be distinct. The rhombus's sum need to be distinct. So if there's not that sum, this current element is not already in best, then we push it there. And then if the best has become greater than 3, so it has more than 3 elements inside, then we pop the smallest one. Okay, so this is a key of the problem, and we're gonna use this function again. And once again, this line is needed because these needs to be distinct. So if it is not already there, you push it into the best array, and then if the length is more than 3, you sort it and you pop the smallest element that goes at the end, because you're sorting in decreasing order. And perfect, now we have all of the degenerate rhombuses, so the rhombuses that are only 1 point. And now we're gonna have to do the ones that have at least a side length of 1. And so to do that, we loop through all of the side lengths that are possible, and the largest side length possible is small divided by 2. So for example, if you have a grid with 100 rows but only 50 columns, the largest side length that you can have is 25. So it's the smallest dimension of our grid divided by 2, right? And then what we're gonna do is we're gonna loop through all of the points that are good candidates for the upper corner of a rhombus. So we're gonna loop through all of the points that can be this corner of the rhombus, or this one, right? Or even this one of this large rhombus. And to do that, we're simply going to start from the 0th row, because we are taking the upper corner, so there's no need to have an offset there. But we're gonna need to stop. Instead of just stopping at grid length, as you usually do, you need to leave room for 2 times our side length, because the rhombus is going to develop downwards from our starting point. So we need to leave room for the rhombus to be constructed there. And the same thing can be said for the columns, except that instead of leaving room for 2 times the side, what we do is we start with an offset of the side already, right? Because you can have your upper corner here. It wouldn't have space for this side right here. So if your side length is 1, then your first column that can be the upper border, the upper corner of your rhombus is this one, right? And also you're gonna have to stop, you're gonna have to leave room to the right of 1. So it's kind of similar to the row, but instead of removing twice the side length, you just remove it once. Okay, so you have an offset to the left and an offset to the right. While on the row, you don't have an offset on the top and you have an offset on the bottom, because we're looking at the top corner of our rhombus. And now we're gonna do a very similar thing to what we did here. So we're gonna calculate our area of the rhombus with this side length, with this upper corner, and we're gonna do the same that we did here. So if we don't have it already in our best array, we push it there, and if it now is greater than 3, the length, then we sort and pop the smallest element. So now all there is left to implement is the calculate area at function. And the calculate area at function is simply gonna have a counter, a result variable, which we're gonna return later on. And then we need to add to this result the sum of all 4 sides. So those are going to be calculated separately. So first of all, we do the side that goes down right? So we're incrementing both the row index and the column index. So we're going to the down right direction, and we go there side length times. So if the side length is 1, then we move in that direction only once. And then we do the same for all of the other directions. So you can see that we literally have the same thing 4 times, except that one time we go down and right. Then one time we go down and left. So we're going back left, but still down with the row. Then we go upwards and again to the left. And then we go upwards and then to the right. So we go back up to the upper corner. So I can show it to you. First of all, we go down right, then down left, then up left, and then up right. And that gives us the result. And yeah, that's it. So I'll submit the solution to show you that it works. And that's it from me. Thank you and bye.